All right, good morning. First and fourth hour Algebra 2 classes. And again, we're in section 10.3, verifying trigonometric identities. Today, all we're doing is simplifying identities. So we'll use this simplification process in the next lesson to verify. So today, example number 2 in your text found on page 629, the directions say simplify the expression. And the expression is rather complicated. It's tangent of the quantity, pi halves minus theta, and there's an understood multiplication process between the two times sine of theta. You will be using, of course, all your algebraic techniques. Some other things that your author does not share with you is that lots of times getting everything in terms of just sine and cosine can be very helpful. Or if you can get something just all in cosine or all in cosecant, sometimes those techniques are helpful as well. So this very first example, example number 2, page 629, there is a value that is equivalent to the tangent of the quantity pi halves minus theta. And that is a cofunction identity, and it is equivalent to just cotangent of theta. So we are asked to simplify, and this is definitely more simple than its predecessor, the line above. Now again, multiplication holds these two together. And I did tell you that, or shared with you that sometimes it's good to get everything in terms of sine and cosine. So I know cotangent has a quotient identity available, and its identity is cosine over sine. Cosine over sine. And if I multiply that times sine, remember sine of theta has a understood 1 under it. Any value has 1 under it. Just as 5 is the same as 5 over 1. Sine is the same as sine over 1. There is now a sign in the numerator and a sign in the denominator, which can be simplified to understood 1. We're left with cosine of theta, and you can change these all to x if you wish. You have cosine theta over 1, which is the same as cosine theta. And that is as simplified as it will go, but it's quite a bit better than where we started. This expression is equivalent to cosine theta. Now notice I worked vertically, and my suggestion is you do the same. Working horizontally, I think is going to cause you problems down the road. So if you guys will work vertically as you go, things will look a lot better, I believe. Another thing you can do, a tool you can utilize, is as you replace something, maybe mark it out. All of this was replaced with cotangent, and cotangent was replaced with cosine over sine. So that might be a helpful tool as well. The next example is example number 3 there in your text. I'm going to move my phone. And you'll notice quite a bit more complicated. It is cosecant theta. If you can see that. It is cosecant theta times the quantity cotangent squared theta. And this one has an addition in it as well. Adding to it 1 over sine of theta. And so again, a lot of different things going on. Matter of fact, all 3 are different. We've got a squared term, we've got a ratio. Nothing really looks alike up here, and so we're going to have to get things maybe looking more alike. So this one has a reciprocal, so it's the same as what? 1 over sine, that's an option. And we have a 1 over sine down here. We have a squared term, that's the first that we've encountered this morning of that. Cotangent squared. Now we do not have an identity for cotangent squared, but we have one that utilizes it. 1 plus cotangent squared is the same as cosecant squared. Okay, So that might be an option too. We can manipulate any of the identities, particularly the Pythagorean identities, to make them a little more helpful. I do know that, again, 1 over sine is the same as cosecant. This one has a cosecant built into it, into the Pythagorean identity, and there's a cosecant here. So I suggest we try and convert them all in terms of cosecant. So let's see what we've got. We can leave the first one alone. It's cosecant theta. I'm doing a terrible job. Cosecant theta. I can do 1 over sine is the same as cosecant, and this is times cotangent squared theta. So I didn't replace anything except 1 over sine with cosecant. That's an option for sure. Things are looking a little bit better. I do note, and like to say, there are different ways to get there, and I may just do it a little bit differently than the author does. This is a product of cosecant and cotangent with a lone cosecant down here. One thing I can do algebraically is factor out a cosecant out of here and one out of here. And that's going to leave us greatest common factor, cosecant theta, and it'll leave us with a, in parentheses, a cotangent squared theta plus, and we have to hold place value. If I'm taking a cosecant out of here and out of here and take it here, I've got to do cosecant times cotangents here. I've got to do cosecant times something is cosecant, and we're going to put an understood 1. Again, I'm kind of doing a little bit different than the author's doing, but I think it's going to work out. So I'm going to go to the Pythagorean identities and manipulate the third one. The third one reads, and again, this is kind of on the side, the third one reads 1 plus cotangent squared theta equals cosecant squared theta. And so I know if I take 1 away from both sides, that cotangent squared theta is the same as cosecant squared theta minus 1. So I'm taking this 1 to the right-hand side. So I'm going to replace cotangent squared theta with cosecant squared theta minus 1. All right, so I've got this greatest common factor, this GCF, still with me, cosecant theta, and I'm going to replace now cotangent squared theta with cosecant squared theta minus 1. So I've got cosecant squared theta minus 1. Now I've still got plus 1 out here, okay? I've got plus 1 minus 1. Now I've got cosecant times cosecant squared theta. And so these are like bases. When you have that, you add the exponents. This should be equal to cosecant cubed theta. That should be simplified. Hope that helps you.